If 72.130 grams of iron 3 sulfate were produced by this reaction, how many moles of calcium nitrate would also have been produced? The first thing I noticed about the problem is that I have a reaction that I'm not sure whether it's balanced. The first thing I'm going to do is make sure that it's balanced. I look at the iron and I have 1 on the reactant side and 2 on the products. I could fix that. So now that I have 2 irons on both sides, I have 2 times 3, I have 6 nitrogens on the reactant side, but I only have 2 on the product side. So if I put a 3 in front of the calcium nitrate, I'll now have 6 nitrogens on both sides. That does make 3 calciums though, which would require a 3 in front of the calcium sulfate. I now have 3 sulfurs, and if I check my oxygens real quick, I have 9, 18 from this compound. I have 3 times 4, 12 from this one, so 30 altogether on the reactant side. I have 12, 9 times 2, 18, 32 altogether on the product side. We are now balanced. Okay, so let's look at the problem. Let's look at the measurement. We have 72.130 grams of iron 3 sulfate. Now, if I have grams of iron 3 sulfate up here, I need grams of iron 3 sulfate in the denominator, or bottom, of the next step, so that those units will actually cancel out. But what can I convert from grams into? Well, whenever we have a balanced reaction, we're going to have a mole-to-mole conversion, where we can switch which chemical we're dealing with in the problem. So I want to take my grams and convert it into moles of iron 3 sulfate. Now, how do I convert from moles to grams? Well, that step will be done with the periodic table. Now, for that, I need to take my 2 irons. I have 3 sulfurs, and I have 12 oxygens in the iron 3 sulfate. So if we go to our periodic table, and I look at my iron, I can see that it has a weight of 55.845, or for this class, we can just round it to 56, and we'll be fine. Sulfur has a weight of 32, and the oxygen has a weight of 16. So 56, 32, 16. If we do the math and add these up, 56 times 2 plus 3 times 32 plus 12 times 16 equals 400 grams per mole. And whatever we add up off the periodic table always equals 1 mole. Whether the coefficient is a 1 or a 2 or a 22, whatever we add up off the periodic table for that compound is always by definition equal to 1 mole. Okay, so now we're in moles, and we can actually start using those coefficients. The coefficients from the balanced reaction generally get used in the problem once. So if I have moles of iron 3 sulfate, I want to convert into the chemical that the problem actually asks about, the calcium nitrate. So I want to convert from the chemical given into the chemical asked about. Now, where do I get the numbers? Well, those, again, are coming from the balanced reaction. Since there's no number in front of the iron 3 sulfate, that's the same as a coefficient of 1. And for the calcium nitrate, we have a coefficient of 3. So when we switch from grams to moles, or moles to grams, keeping the chemical the same, then we're using the periodic table. But in a problem, or in a step, where we convert from one chemical to the other, we stay in moles before and after, but the chemical changes. These are the ones that we use the balanced reaction to solve. Now, the problem asks for moles of calcium nitrate, and we are actually right now in units of moles of calcium nitrate, not nitrate. So, when the units match what the question asks for, we're going to be safe to pop in an equal sign and do the math. So 72.130 divided by 400 multiplied by 3 equals 0.54098. Since we start off with 5 significant figures, we need to make sure that we have 1, 2, 3, 4, 5 significant figures in our final answer. But our answer also needs units. And in this case, the only things that have not canceled out for units are the moles of calcium nitrate. And this would be our final answer.